Okay, we're going to talk about the second part of lesson 56, which is proofs. So if you would please draw these two shapes. I'm going to label this angle 1, angle 2, and angle 3. Before, we talked about that the measure of angle 1 equals the sum of the measure of angle 2 plus the measure of angle 3. So whenever you have this exterior angle here that kind of extends outward from a triangle, so this exterior angle right here is equivalent to the sum of these two, right? Because this angle plus this angle right in here, so these two angles are supplementary, right? Which means they add up to 180. Well, so do these three, right? These three angles on the inside add up to 180. So therefore, that these two angles must be the same. The sum of these two angles must be the equivalent to angle 1. We already talked about that. However, I don't want to say however, if I'm going to add on to this, right? So I'm going to take this shape here. I'm going to put it inside. What am I doing? Let's not do this. Let's do it the other way. Let's take and put my circle around this, okay? And what I'm going to do is I'm going to extend these lines. Okay. So I now know no, let's not do this. Sorry, guys. I'm getting. Let's just draw a circle. Sorry, I'm choking. I'm going to draw a secant line here. A secant line here. And then I'm going to connect with a chord, like so. Okay. And from there, I'm going to label these, right? These angles are the same because they're vertical angles. And what I want you to focus on right now is just looking at this, okay? So I have a very similar picture. Let me see if I could. If you look at this piece right here, doesn't this look like, maybe I should highlight it. If I were to take this, doesn't that outlined yellow look a lot like this picture right here, right? And what I know is that angle 2 is an inscribed angle because the vertex is on the circle, and angle 3 is an inscribed angle because the vertex is on the circle, all right? So now, what I can say is if I wanted to do this, right? I can say that the measure of angle 2 is half of my intercepted arc here. All right, whatever that is. So I can say the measuring of angle 2 is half of this arc. I tell you what, guys, I'm not doing too hot today. Oh my gosh, I'm still doing it. It's half of the arc, right? I could say the same thing about angle 3, right? Angle 3, there's my intercepted arc. So I could say that the measure of angle 3 equals half of that intercepted arc. So if I want you to just be able to use these properties, use what you know, because you're going to be using, you're going to be given these diagrams, and you're going to have to find measurements. And that's what a geometric proof is. It's just knowing all of the properties and theorems and postulates in geometry to prove that things equal what they do. So here you have a triangle where all of these angles have to add up to 180. You know that this angle 1 and angle 1 have to be congruent because they're vertical angles. You know that angle 1 is congruent to the sum of angle 2 plus 3, okay? Because that's the exterior angle theorem. So it's using, proofs are nothing more than using the properties, theorems, and postulates of geometry to prove, to prove that things have value, or to have a certain measurement, and why relationships exist. So I don't want you to get too overwhelmed in the whole proof process. I'm not going to make you do pages and pages of 2-column proofs. I just want you to understand what they are and know that when you're finding angle measurements or line segment measurements, you can fall back on all of these theorems, postulates, and proofs. So there is just an idea of how to use proofs, how to use the properties, and we'll be practicing them more as we go through all of these, the rest of this textbook.